All right, before we get into the specifics of all the lessons plans and you get started on your presentations and everything we've got to do for the class, first we need to talk about the intro to digital forensics and what exactly digital forensics is. So digital forensics is a branch of forensic science. It's the recovery and investigation of data found on a digital device. Most of the time, this recovery and investigation involves computer crime and works alongside law enforcement. The primary goal of digital forensics is to preserve any evidence in its most original form, collect this data, and then to record it for use. The information itself may be used in a court of law or an internal case for company purposes. A majority of the time, digital forensics is used after a crime has happened, and digital forensics specialists will try to recreate what the attacker did find in the information to help solve a case. However, there are also many challenges in the digital forensics field. One prime example is how someone can duplicate or preserve evidence without knowing the duplication itself inherently or if the data has been changed. This is a key concept because the data cannot be tampered with in any way, otherwise it will be invalid. Another way that the field is difficult to bid is because of timelines, which are very critical for showing who did what and when, but the digital timestamps are notoriously absent or can be easily spoofed in digital data. The result is more invalid data and makes digital forensic experts' job quite difficult. The last and probably the most important piece of information is that in order to be able to state conclusively that action A caused result B, the concept of repeatability must be introduced. This is very difficult with digital forensics because if you cannot repeat the actions you took to recover the said data, then truthfully the data is considered invalid. Many times, digital forensic experts will be called into a court of law and asked to replicate how they recover the data in order to convict a criminal or prove the innocence of the subject at hand. So how is digital forensics used in the real world? There are many examples of high-profile cases that most people have heard of, but it is relatively unknown that the key pieces of information that convicted each criminal were secured using digital forensics. One great example of this is the case of Dr. Conrad Murray, an extremely high-profile case that involves Michael Jackson's physician. Now, his case wasn't entirely decided by computer forensics, but it certainly didn't help him that the investigators were able to find medical documentation on his computer showing that he authorized lethal amounts of propofol, which was pretty much what killed the deceased pop star. Without digital forensics, the courts would not have had the smoking gun to convict Dr. Conrad Murray. Another case involving digital forensics is that of the BTK killer. This is probably the most famous use of computer forensics to crack a case. For over 30 years, police had tried to use traditional evidence to track down this man, who had strangled a number of women over a period of 16 years, from 1974 to 1991. During his reign of terror, he often taunted police with letters and poems, but no one could ever link the killings to anyone. Then, after 10 years of silence, he sent the police a floppy disk with a Word document in 2004. Within just a few hours, computer forensics experts were uncovered metadata on the disk that connected it to a dentist at the Christ Lutheran Church. This turned out to be Dennis Rader, who later admitted to the crimes in an excruciating detail. One last case that the digital forensics helped to convict a criminal is that of Krinar Lusha. When his laptop was searched by UK, the computer forensic experts discovered that he had downloaded instructions on how to do a number of frightening things, like build suicide belts and other types of explosives. He also commonly had live chats with people who talked about things wanting to become a terrorist and wanting to see Americans and Jews killed. All of this led to a search of his apartment, where officers found bomb-making equipment and plenty of other weaponry. Needless to say, he won't be trying it out anytime soon. Now that it has been addressed what digital forensics is and how it is used every day to solve real cases, it needs to be discussed that it's different from cybersecurity. While cybersecurity and digital forensics often overlap, they have entirely different purposes. A cybersecurity analyst is in charge of preventing attacks from happening. They will make sure a company has strong firewalls, passwords, and measures in place if a cyber attack does in fact happen. This is entirely defensive, as opposed to a hacker being offensive. It's work that uses computers to a great deal to protect important assets. Digital forensics, as we've already explained, is the field of recovering data for investigative purposes in relation to a computer crime. The basic rule to remember is that cybersecurity is about preventing computer crime. The basic rule is that we need to make sure that digital forensics is about solving computer crime. So the difference there is that cybersecurity, we just want to prevent crime. We want to make sure it doesn't happen. But digital forensics is all about computer crime that's already happened. We want to make sure what happened and how we can fix that. So now with the basic understanding of what digital forensics is and how our digital forensics workstation will fit into that, now we're going to dive in a little bit more with a lot more of our lessons plans so that you can get a full understanding and knowledge of what digital forensics is, how you can use it, and many of the tools that it offers.